This vanilla yogurt costs $1.49. This vanilla bean costs $3. Both carry the word vanilla on the label. But here's the crazy part. That yogurt has almost certainly never been within 1,000 miles of a single vanilla plant. And the law doesn't require the label to tell you that. Today we're breaking down the biggest flavor deception in the modern food industry. How one of the world's most expensive agricultural products was systematically replaced, first by wood pulp, then by a petroleum derivative, and now by living organisms in a steel tank. How a legal loophole allows food companies to sell you synthetic flavor labeled as natural. And why the vanilla of the future won't come from a farm or an oil refinery. It will come from an engineered microorganism inside a bioreactor the size of a warehouse. Stay until the end, because the label system is more broken than you think. And once you understand how it works, you will never read a vanilla label the same way again. To understand the deception, you first need to understand the supply chain it replaced. Vanilla comes from Vanilla planifolia, a tropical orchid, and it is one of the most labor-intensive agricultural crops on Earth. Each flower opens for only a few hours. Miss that window and the plant produces nothing that season. Outside of Mexico, there are no natural pollinators for vanilla. Every single flower must be pollinated by hand. One worker, one flower, one at a time. After pollination, pods take 6 to 9 months to mature. Then comes curing, blanching, sweating, slow fermentation, sun drying, another 3 to 6 months. From first flower to finished vanilla bean, nearly a full year of labor before a single gram of flavor is ready for sale. Madagascar produces roughly 80% of the world's natural vanilla. The entire global harvest produces the equivalent of only about 40 tons of pure vanillin per year. Think about that for a moment. One island nation, thousands of smallholder farmers, hand-pollinating individual flowers, trying to supply vanilla flavor for ice cream, yogurt, protein powder, coffee, cereal, and bakery products consumed by 8 billion people. The math has never worked. And in 1874, two German chemists named Tiemann and Harman understood exactly why. They isolated the molecule responsible for vanilla's taste and aroma. Then they figured out how to make it without ever touching a single vanilla plant. That molecule is called vanillin. It is the primary flavor compound in real vanilla. And the discovery that changed the food industry permanently was this. Your tongue cannot tell the difference. Whether vanillin comes from a vanilla bean, a petrochemical reactor, or a fermentation tank, the molecule is structurally identical. Same atomic shape, same bonding, same interaction with your taste receptors, same flavor, same aroma, completely indistinguishable. Food scientists understood the implication immediately. Consumers were never actually buying vanilla beans. They were buying the sensory experience produced by vanillin. That single insight launched an industrial revolution in flavoring that reshaped global food manufacturing over the next 150 years. Pattern interrupt. Here is how the industry actually makes it. The first commercial process used lignin, a byproduct of the paper and pulp industry. Wood waste, chemically converted into vanilla flavor. Today, the dominant production method uses guaiacol, a compound derived from petrochemical feedstocks. Guaiacol enters a chemical reactor. Temperature, pressure, and catalysts convert it into vanillin. Purified, crystallized, and packaged. Final cost to food manufacturers, approximately $15 per kilogram. Compare that to premium natural vanilla extract, which costs between $300 and $600 per kilogram, a price gap of 20 times. Global synthetic vanillin production now exceeds 20,000 metric tons per year. Natural vanilla produces the equivalent of roughly 40 tons. In other words, synthetic vanillin outproduces natural vanilla by a factor of 500 to 1. But here is where it becomes genuinely strange. Some of that 20,000 tons is legally sold to you, right now on grocery store shelves, labeled as natural flavor. Before we get into the label loophole, and this is the part that will permanently change how you read food packaging. If you have watched this far, you are exactly the kind of person this channel is built for. Hit subscribe. Every week we break down the engineering and the hidden systems behind the products you use every single day. Now, the label. In the United States, the FDA defines natural flavor as any flavor compound derived from a natural source. That source can be a vanilla bean, but it can also be a microorganism fed on plant-based sugar inside an industrial fermentation tank. Companies including Evolva and Givaudan have developed industrial fermentation systems where genetically engineered yeast strains produce vanillin from plant-based substrates. The vanillin they produce is chemically identical to the molecule inside a vanilla bean. And under current FDA labeling rules, that product can be sold to food manufacturers and appear on your label as natural vanilla flavor. Think about that for a moment. Not because it came from vanilla, but because a living organism produced it, even if that organism spent its entire existence inside a stainless steel reactor on an industrial campus outside of Geneva. Here's the label guide the food industry does not want you to have. Vanilla extract means real vanilla beans were used, always. Vanilla flavor means synthetic vanillin, almost certainly derived from petroleum-based guaiacol. Natural vanilla flavor means biofermented vanillin, real extract, or a blend of both, almost certainly not from vanilla beans. And artificial vanilla flavor is the only label that is fully transparent about what it contains. The label that sounds the worst is often the most honest product in the aisle. The labeling strategy goes deeper than ingredients. It extends into visual psychology. And nowhere is this more effective than premium vanilla ice cream. What makes a vanilla ice cream look expensive? The answer is immediate and universal: those tiny black specks. And food companies understand this with extraordinary precision, because perception of quality begins before the first taste. Color, texture, and visual cues prime the brain to expect a specific flavor experience before a single bite is taken. But here is what those black specks often actually are. They are frequently added separately from vanilla bean extract, contributing appearance and the visual signal of authenticity while delivering minimal actual flavor. The flavor itself in the same product may still come entirely from synthetic vanillin produced in a chemical plant. Studies have confirmed this repeatedly. An identical product with visible black specks is rated as higher quality, more premium, and better tasting than the same product without them. Same formula, same synthetic vanillin, different consumer perception, different price tolerance. Häagen-Dazs is one of the few mass-market brands where vanilla actually means what most consumers assume it means across their full product line. They advertise real vanilla beans, and they deliver. Most store-brand vanilla products carry no such commitment. In modern food production, engineering is not only chemistry, it is perception design, and vanilla is its most refined expression. For over a century, the choice in vanilla flavor was binary: natural vanilla from Madagascar, or synthetic vanillin from petroleum chemistry. Today, a third option is scaling rapidly, and it changes the entire picture. Biotechnology companies including Evolva, Givaudan, and Solvay have developed industrial fermentation platforms where specialized microorganisms, engineered yeast and bacteria, convert plant-based feedstocks directly into vanillin. The process has no resemblance to farming. It resembles brewing at industrial scale. Large bioreactors, controlled temperature, continuous nutrient feed, biological conversion monitored by computer systems around the clock. The result is chemically identical vanillin, produced without a single liter of petroleum and without a single hand-pollinated flower. And as established, under current FDA rules, it qualifies as natural flavor. The irony is considerable. The vanilla flavor of the next decade may come from neither farms in Madagascar nor refineries in Europe. It will come from microorganisms living in tanks the size of a warehouse, biology and engineering working together to replace one of agriculture's most demanding crops. The next time you pick up a vanilla product, flip the label. Vanilla extract, you are buying the real thing. Vanilla flavor, petroleum chemistry. Natural vanilla flavor, a bioreactor, a field, or both. The label won't specify. Artificial vanilla flavor, the one label that is actually honest about what it contains. Here's what this story is really about. A tropical orchid with a 12-month production cycle inspired a global industry. Chemists isolated its most important molecule. Engineers learned to synthesize it from wood pulp, then petroleum. Biotechnologists are now growing it inside living organisms at scale. The vanilla on your label has followed a 150-year arc from farm to chemistry lab to fermentation tank, and most consumers have never once been told. If you want to know which other ingredients in your kitchen went through the same transformation, subscribe to MadeMass and drop a comment. Now that you know what the labels actually mean, are you checking next time you shop? Subscribe for more deep dives into the engineering behind the world's most iconic products.